think we're good. Okay, so in this, we're just going to create a couple surface types. You can technically just do it even from plan view, or you can actually make a 3D model. You'll have to kind of separate some of the surfaces a little bit more, but that shouldn't be a huge issue. For this, I'm just going to start off with a rectangle surface. Let's do it as like, I don't know, 500 by 800. That way we have a decent sized surface. And I'm going to just use my line tool or P-line to start to break this apart into different pieces. So I'm going to start off with this P-line. Again, you don't have to have it exact. We just want to have a couple different types of surfaces. So I'm going to draw a line over here, hit enter. I'm going to make a copy of it. I always forget how to do this. There we go. So we got, this could be our road or something. Then I'm going to create just some boxes over here. And let's do one more over here. So like I said, just try and create something. So I'm going to take this surface and just split it with all these curves. This is how easy it is. So now I've got this type of surface, these surfaces, that one, and that one. And I'll start to kind of tell them what they're going to do. So let's say this one is a building. Let's move that to a new layer. I'm going to label it building. I'll make this one a parking lot. I'll label this one as ROAD. And so then we have park. And now we have, let's make this last one is going to be concrete. So I've got 1, 2, 3, 4, 5 different surface types. Everyone's got at least some variety of surfaces. Okay, so let's go ahead and start to put the script together. So again, this is going to just require a lot of us. I mean, this is what it's really going to look like. It's just that you've taken this part and this is essentially starting to kind of figure out your surface types. In this one, I see that I have 4 different areas for my surface type. They get kind of averaged out for their CN value. Then they get calculated for your runoff amount, and then that generates into runoff volume. So it's really, if you were to think about it, it's really just this part that you're having to create as unique values. The rest is just like a copy and paste. So I'll just create a new one to start from scratch. And like I said, we're just going to essentially do this for one surface type, and then we'll copy it for the other ones. So let's start off with our building surface. I'm going to bring this one in, say set one surface. I'm going to select the building. I'm just going to label it building. Thank you. So there's our building. Let's turn that off. We need to find the area of it. So I'm going to type area. That's giving us area in square feet. We actually need these converted into acres. So I'm going to take this value and divide it by what? Anyone know? 4. How do we convert square feet to acres? Dividing it by an acre, which is how many square feet? So 43,560. Yay! I'm going to take that into there. That gives me this acreage. We're going to have to do a little bit of kind of like backtracking, but that's okay because we're going to have to actually find the percentage of like how much the parking lot or how much the buildings are taking up of this space. So actually, like, what I could do is just select all my surfaces here. This will probably make it easier. And I'm going to say set multiple surfaces, find their area as well, divide it by 43,560. So now I have the total acreage of the site. If I do a mass addition of it all, gives me a little over 9 acres. And so in order to figure out how much percent my building takes up, I need to divide its acreage by the total acreage. So I'm going to take this value and divide it by this value. So now I have a percentage. So around 17% of the site. I take that percentage of the site and multiply that by its CN value or its curve number value. Who remembers what the curve number value represents in relation to a stormwater calculator? Remember, we're dealing with surface types. So it's pretty much the same thing as a coefficient. So each one of these surface types has their own unique curve number value or its own CN value. Parking lots, buildings, sidewalks, asphalt are all going to have very similar CN values. Instead of the values being between 0 and 1, like in the rational method, they're between 0 and 100. So they're really kind of, they work in the same kind of fashion where in a rational method, like a 0.98 means it's going to have a lot of runoff. Same thing with the CN values. The higher the value, the more likelihood of runoff occurring. So these ones have a CN value for the most part of 98. So a lot of them, except for probably this park area that I have. But we still want to separate them because we can just change each one individually. So we can change the building to have a green roof, whereas the parking lot has porous pavement. They have different CN values. So that's why you kind of want to separate them, even though a lot of them are going to have the same value initially. So I'm going to take this one and multiply it by 98, because that's what the CN value is. I'm going to rename this CN value. So there's that one. And so from here on, I'm going to go ahead and create another mass addition. This is where we're going to take all of this part and copy and paste it several times and group it all into this one. So we're going to rename this mass addition one that I just created. I'm just going to label this weighted CN. It's essentially going to take all these values and accumulate them together. So like I said, I just have to copy and paste this one, re-reference a different surface type. So I'll label this one parking lot. I set one surface and select this purple rectangle, which is my parking lot. And now I can hold shift and drag that into here. You'll see that this has a weighted or a CN value of 16. This one has 17. Now they start to add up to now it's actually 34. So I'm just going to do this 3 more times. So I'll label this one. Let's just label this concrete surface. Set multiple surfaces, so this one and this one. So if that ever occurs, if you have multiple surfaces of the same type, you actually probably want to do a mass addition here too. So you can see that it's giving me 2 values. Those are all going to get put together separately, and that's kind of a pain. So we actually want to use another mass addition, put it over here, and drag that into there. So now it's actually adding up all the square footage, dividing it by acreage, and giving us one single value. I'm going to drag that one up to there. Let's do this 2 more times. So I set one surface. This is going to be our row add. That's how I knew Alex was missing, because he would have gotten that reference. Add that over here. And one last time for our park. We're going to add that over here. So the other thing we have to do is, because we're just copying and pasting, like I said, for the most part, they all have their own or similar CN value. However, there are some that have different values, so such as the park. Does the hydrology group happen to have that sheet that was handed out yesterday? So give me, what do you think this park should actually be? So it's probably something on the second page in the first top one. Yeah. I mean, it doesn't have to be technically a park, but some kind of soft surface. Okay, what do you think this should be? What condition is that? So we'll change this one to 86 now. So let's just undo that real quick, because you'll see oops, I don't know why I didn't change that. So if I kept this one at 98, you're going to see that this weighted CN value is probably going to be 98 as well, right? They're all 98. There's nothing for it to change. So if I were to actually change this to that 86 value, now you see that it's going to account for that, and now it's around 96.9 as its weighted CN value, because the majority of it's all 98, but then you got this little slither of an 86 value that kind of averages out. So do you all kind of understand this concept of a weighted CN value? That you're just calculating all the different areas, the actual square foot or acreage of your site, assigning it its own CN value, and calculating them all up and finding that average. Okay. Okay, so we got our weighted CN value. Now we get to be a little bit more complicated. I don't know if I have that calculator on hand, but I'll just reference the old one. So this is where we're at right now, is our weighted CN value. The next thing we have to do is actually figure out our S value. So that is going to be this kind of formula. You're going to take your weighted CN value, divide it by, or you're going to take 1,000 and divide it by that CN value and subtract 10 from it. Makes perfect sense, right? That's what I thought. Because it makes perfect sense to me. Not really. So we'll take, again, I'm just going to write 1,000 because this is a static value. This won't be changing at any point. So that kind of helps you all understand or remember, like, if it's a slider, it's probably going to be a variable that changes. If it's something in these kind of sticky notes or these panels, it's not going to change. So I'm going to take that value, divide it by my weighted CN value. Then I'm going to subtract that value by 10. So we can do CN value. That's what this is creating. Maybe we change the color so it just pops a little bit. And then this is going to be our S value. Change this color as well. Okay, so now we take that value and we're going to take it through this little rigorous process. So we take that S value and we're going to do two different things with it. We're going to multiply it by 0.02, subtract that from our precipitation value, then we're going to find the square root of it. Makes sense to me. Let's see if I can remember all that. Yeah. So I'll create my precipitation slider. I'll do 0.25 less than 6, I guess. So again, I'm going to subtract this value from the precipitation, right? I think so. I think I already botched this. Yes, I did. So first, let's multiply that the S value by 0.02. Never remember how to disconnect that one. So we're going to multiply this value by 0.02. 2. And then we're going to subtract that value from 1, or the precipitation. Then we're going to find the square root. I'm going to go to operations, square. So this is half of the equation. And now I'm going to also do something very similar, but we're going to take that against S value, multiply by 0.8 this time, and then add that to precipitation. Awesome. So I'm just going to copy and paste this, change this to 0.8. I'm going to add this to the precipitation value. So there's that part of the equation. Now we're going to divide them by each other. So we have this top part that we're going to divide by this bottom part. Oops. And so that should give us our actual runoff in inches. And this is where it's a little confusing. You're going to see that it's a pretty small value. Let's actually jump this precipitation to 1 inch so you have a better understanding. So you have 1 inches, a 1 inch rain event, and from this it generates 0.69 inches of rain or runoff. So what this means, again, it's not runoff volume, it's just runoff units. So it's essentially close to 70% runoff value. So you have 1 inch runoff that's occurring is going to be 0.7 inches or 0.7, yeah, 0.7 inches. So it's not actually any volume, it's just a matter of ratios. So it's about a 1 to, or a, yeah, it's about 70%. Right. And the reason that it's like that, and this is where it gets like extremely complicated and everything. So like if 1 inch equals almost 0.7 inches of runoff, what would logic tell you that 2 inches would produce? Double it. Let's just say it's double it, right? That makes sense. If 1 equals 0.7, this should equal 1.4. Oh, wait, it's 1.66. So it's not exactly doubles it, and this is why. So what do you think's happening? What do you think the difference is between like a 1 inch rain event and 2 inch rain event? Why would that generate more runoff? Whole time. What's that mean? The ground becomes more saturated, right? So that's what it's actually starting to account for is that, okay, like a 2 inch rain event, that's probably going to last longer. That's going to cause the soils to become more saturated, the surface types to become more saturated. So it's starting to kind of become more impervious, so to speak, because that saturation starts to act as a barrier from infiltration from occurring. And the same thing applies if you were to think, again, if 1 inch equals 0.7, you'd think, okay, and then 3 inches is going to equal 2.1. Oops, let's not do that. It's 2.6, so it starts to even escalate even more. So that's why this equation gets. And then you can see when it's 6 inches, it's almost 6 inches of runoff. It's 5.6. It's pretty close because of how much rain has occurred over that time. It shouldn't ever meet that runoff because there's always going to be that initial infiltration. That's what this part of the equation is doing. It's called the initial initial abstraction, I think, which is what's accounting for saturation levels. So we've got our runoff in inches. I'm going to bring this back to 1. How do we turn that into runoff volume? No. The information's here already. So like I said, this hasn't been converted into volume yet. It's just accounting for, it's just a ratio, right? So it's for every 1 inch, you get 0.7 inches of runoff. So how do we make runoff into volume? It's just 1 unit. It's a ratio, right? Yeah, the area. So the site area. So we need to multiply that by the actual site area to turn that into volume. So you have to imagine, like, if these were 1 square foot modules, then you apply that 0.7 ratio to every 1 foot module, and that starts to give you that sense of volume. Like, that's obviously not the exact module size, but then, so we actually need to multiply that, or we have to do one more thing before that. So we're taking our, so we have to do a couple conversions because we're dealing with inches of runoff, and we're looking at square feet. So the first thing we need to do is convert this runoff in inches into feet of runoff. So we need to take that value and divide it by 12. So now that number is going to shrink even more. But now we're going to multiply that by, instead of, this is giving me acres. We have to convert now that acres to square feet. I'm going to give myself a little bit of space. So I'm going to now take that value, multiply it by, how do I convert acres to square feet? Multiply 43,560. Oh no. So now we got square feet, runoff in feet. Now we're just going to multiply these two values together. So we got our conversion of the site size and the conversion of our runoff. And now we can see that we have generated over 23,000 square feet of runoff. So pretty substantial. So here's the cool thing is, like I said, where you can start to now create a responsive solution. You can now imagine converting this parking lot to what? What do you want to convert that parking lot into? Good call, Fatima. So grass. So let's go ahead and do that. So here's our, where is it? Parking lot's right up here. So Susie, what's the CN value for a park? This is like your green improvement section. Yeah, or something that would serve as a park. 74? Okay. So now, if I were to, so remember, 23,000 gallons, what was it again, 74? So I'm going to change that into that green improvement. Now I've jumped it down to 14,000 gallons, or 14.5 cubic feet of runoff. So pretty drastic improvement. What can we do to the building? Green roof, good. What's the, you can make it taller, it's not going to change it. So Susie, what's the CN value for a green roof? Bless you, bless you, bless you, bless you, bless you, bless you. Is that coughing or sneezing? Both. Okay. Yeah. $75. Sweet. Now we got a runoff volume of only 9,000. So we're getting pretty close to dropping. So you can see like how easy it is to start to create kind of alternative strategies. This is just simply just changing the footprint to different values. You can even start to say, you know what, maybe I want to now expand some of these areas. So you can even start to change the size of the geometry to do similar things and have it all kind of respond in the end. Something that's cool, let's see if we can get it to work. I'm going to take this parking lot. So let's change that back to, what was it, 98 and 74. So I'm going to just change this to be a max of 98 and a minimum of 74. That way it just kind of changes between those two values. So what you can do is I'm going to give this an actual display color looking kind of like that. Let's make it nice, dark. Let's hide. Okay. So what you can actually start to do is get a little bit complex in terms of changing this to actually start to look like a park or like kind of create a fun little animation, so to speak. So you know this value is going to create this. You want this value to create this kind of tone. And then you want a smaller value. So between 13 and 17 to change these values. So I haven't done this in a while, but I know it works. So we can actually say, I mean, luckily the parking lot's very dark, so it just seems like it's void of color, right? So I can take color HCl, which is hue, saturation. So there's hue, saturation, and I think this is luminance. The alpha, that's just its transparency. So I can say, so let's find a green hue. Let's make it a little more yellow. That looks good. Let's just do it 90. Let's just make it very vibrant. So what we're going to do is say, so let's do 80 as our hue. The saturation is at, we could probably even do it as, change our values. So we want it to look like this color. So let's say 58, our saturation. And really what we want to make kind of responsive is our, I think this is the one. Which one is this? No, we do want to do that. Yeah. So we're going to say 58 is our good value, and then That's weird. Let's try. Hmm. Huh. Maybe this here. Maybe this. Okay. There we go. Like I said, it's the saturation that we're going to affect, which is about 0.74 is good. Then if it's low, so we're going to remap this value. Or no, let's do it easy, even easier. So this should take A divided by 100. Oh wait, let's do it. Let's see what that does. So it really gets a little messy. Let's just get this. I'll show you another time. Okay. Any questions for this calculator? All right.